there's a quiet eye above our world. For more than 3 decades, it has watched not through the noise of rockets or the chatter of radio, but in silence. Orbiting Earth beyond the reach of clouds, it opens its gaze to the infinite. This is the Hubble Space Telescope, humanity's window to the universe. Through it, we've seen the birth of galaxies, the death of stars, and the beauty of worlds we've never touched. But today, let's turn its gaze closer to home, to the planets, moons, and fragments of our own solar system, the places where sunlight still holds stories of creation and where discovery continues right next door. I'm your guide, and this is Cosmic Compass, where we follow the light wherever it leads. For more than 3 decades, a lone observer has circled high above our planet, silent, steady, and unblinking. Launched in 1990, the Hubble Space Telescope has become one of humanity's most successful scientific missions. We often think of Hubble as the explorer of distant galaxies, capturing light that has travelled for billions of years. But that's only part of its story. Although it was never designed to study our solar system, Hubble has turned its gaze inward countless times, revealing remarkable details about the worlds that share our sun. Today, let's take a journey through our cosmic neighbourhood, guided by Hubble's eyes. From the glow of our moon to the icy edges beyond Neptune, we'll see how this telescope has captured moments that would otherwise have slipped unnoticed into history. Our first stop is close to home, the Moon, Earth's silent companion. You might assume that with such a large bright target, Hubble would have studied the Moon extensively. Yet it rarely does. The Moon's size and brightness make it difficult to capture in a single frame, and other spacecraft already photograph it in far greater detail. But in 2012, something extraordinary happened. As Venus passed in front of the Sun, Hubble used the Moon in a way few could have imagined as a cosmic mirror. Instead of looking directly at the Sun's blinding light, Hubble observed the sunlight reflected off the Moon, searching for faint variations caused by Venus's atmosphere filtering that light. This clever experiment wasn't meant to study Venus. We already know its atmosphere well. Instead, it tested a technique for detecting the atmospheres of exoplanets. By examining how light changes as it passes through a planet's air, astronomers can determine what that atmosphere is made of. In that single experiment, our own moon helped Hubble refine a tool we now use to search for life far beyond our solar system. Moving outward, we reach a planet we know well, yet one that continues to surprise us, Mars. Hubble has observed Mars many times over the years, capturing full disk views impossible for orbiters that fly close to its surface. These images reveal global dust storms, shifting clouds, and subtle seasonal changes, reminders that this desert world is still alive with activity. In one striking time-lapse, Hubble recorded a planet-wide storm that engulfed Mars, hiding nearly all of its surface beneath swirling dust. Even its 2 tiny moons, Phobos and Deimos, could be seen racing around the planet, in the background small fast-moving shadows against the glowing red world below. Phobos, in fact, orbits Mars in just 7.5 hours faster than the planet's own day. That makes it the only moon in the solar system that rises and sets twice each day. Through Hubble's eyes, Mars is more than a target of exploration. It's a living, breathing world of dust and storm, constantly changing under the sun's gaze. Between Mars and Jupiter lies a region that defines both beauty and destruction, the asteroid belt. From afar it might sound empty, but it's home to millions of rocky fragments, each following its own fragile path around the Sun. In 2019, Hubble turned its attention to asteroid 6478 Gault, and what it saw defied expectations. Instead of a solid rock, it appeared like a comet trailing 2 long tails of dust. The explanation lies in a subtle but powerful force known as the Europa effect, the way sunlight can cause irregularly shaped asteroids to spin faster over time. As Gault's spin increased, centrifugal forces began flinging dust and rock from its surface into space, forming its ghostly tails. Eventually, such asteroids may tear themselves apart, completely reduced to drifting rubble. In another case, Hubble captured a far rarer event, two asteroids colliding. The object known as P 2010A2 appeared to have a delicate X pattern near its centre, the unmistakable sign of debris flung outward in all directions, slowly falling back toward the impact's heart. For the first time, we witnessed an asteroid collision frozen in time. In these snapshots, Hubble showed us that even in silence, the solar system remains restless, still sculpting itself through cosmic violence. Beyond the asteroid belt looms the giant that dominates our planetary family, Jupiter. This immense world holds nearly 3/4 of all planetary mass outside the Sun. Its gravity shapes the orbits of comets, deflects asteroids, and in many ways protects the inner planets, including us. But sometimes that protection turns catastrophic. In 1994, a comet named Shoemaker-Levy 9 ventured too close to Jupiter. The planet's gravity ripped it apart into more than 20 fragments, each one falling back in a sequence of titanic impacts. Hubble was there to witness the spectacle. Fireballs thousands of kilometers high erupted above Jupiter's clouds, glowing hotter than the sun's surface. The largest impact left a dark scar wider than Earth itself, a wound that lingered for months. It was the first time humanity had seen a collision between two celestial bodies in real time. Through Hubble's lens, we glimpsed the raw power that shapes worlds and the reason our own planet still exists in relative peace. Yet not all of Jupiter's wonders are destructive. Hubble has also captured something far more ethereal, auroras dancing around its poles. Unlike Earth's, which flare briefly during solar storms, Jupiter's auroras never stop. They burn hundreds of times brighter than ours, sustained not by sunlight, but by charged particles trapped in the planet's immense magnetic field. Together, Hubble and NASA's Juno spacecraft revealed this hidden heartbeat of Jupiter, a planet both protector and storm, forever glowing at the edge of space. Orbiting Jupiter is one of the most extraordinary worlds ever discovered at Europa. From the outside, it looks silent and frozen, a sphere of cracked ice reflecting pale sunlight. But beneath that shell lies one of the greatest mysteries in the solar system, a vast ocean of liquid water. Hubble's ultraviolet vision detected plumes of water vapor erupting from Europa's surface, proof that something stirs beneath. It also found traces of sodium chloride, ordinary table salt on the moon's icy crust. This salt likely came from the hidden ocean below, brought to the surface by those same plumes. If that ocean touches a rocky seafloor, it might also host hydrothermal vents similar to the ones on Earth, where life thrives without sunlight. Every discovery strengthens the case that Europa may harbour the conditions for life. Hubble has never touched its surface yet. From hundreds of millions of kilometres away, it's helping us search for our closest cosmic neighbour's life that might exist beneath an alien sea. Our next destination is the planet that has fascinated humanity for centuries, Saturn. Since the Cassini spacecraft ended its mission in 2017, Hubble has become our primary window into Saturn's ever-changing atmosphere. Each year, it captures storms drifting across the golden bands, revealing patterns that shift with the seasons. Hubble's long-term perspective fills in the gaps that Cassini never had the time to see. Half a Saturnian year that lasts nearly 3 decades. Some storms stretch thousands of kilometres, swirling like brushstrokes painted by unseen hands. And beyond the data, Saturn remains an image of beauty, itself a planet so perfect in symmetry that it reminds us why we look up in the first place. Through Hubble's eye, science and art blend seamlessly, revealing a world as elegant as it is immense. Next, we reach a planet that refuses to follow the rules, Uranus. Unlike every other world, Uranus rolls on its side, its poles pointing almost directly toward the sun. This gives it some of the strangest seasons imaginable, with years of sunlight followed by years of darkness. In 2006, Hubble captured something never before seen, a shadow cast by one of its moons, Ariel, crossing the face of Uranus, a rare event, only possible once every few decades. It also tracked subtle changes in the planet's colour and brightness, evidence of evolving weather systems and shifting cloud caps as Uranus slowly moves through its long orbit. Its blue-green hue hides fierce winds and deep mysteries beneath. Through Hubble's steady gaze, this tilted planet no longer feels so distant. It becomes a reminder that even the strangest worlds still dance to the rhythm of the same sun. We know. At the outer edge of our solar system, where sunlight is weak and the stars burn brighter, lies Neptune, the last great planet. Only one spacecraft, Voyager 2, has ever flown past it. Yet, thanks to Hubble, we continue to watch Neptune's shifting clouds and vast storms from afar. One such storm, the Great Dark Spot, has appeared and vanished over the years, reminding us that even this cold world is alive with change. But Hubble did more than observe Neptune's weather. In 2013, it discovered a new moon, Hippocamp, a tiny irregular world just 35 kilometres across. It likely formed from debris blasted off the larger moon Proteus after a massive impact. There's a quiet poetry in this discovery, a fragment of a moon born from destruction, now circling in the dark, unseen, until Hubble's patient eye revealed it. Even at the farthest reaches, our telescope continues to uncover stories of lost creation and renewal. Beyond Neptune lies a region almost untouched by sunlight, the Kuiper Belt, a vast realm of icy worlds left over from the solar system's birth. Among them drifts a dwarf planet with a strange name, Gong, officially known as 2007 OR10. It's the third largest dwarf planet we know after Pluto and Eris. Hubble didn't discover Gong, but it made an important revelation: this distant world has a moon of its own. Astronomers suspected it after noticing Gong's unusually slow rotation, about 45 hours long. Only when they examined old Hubble data did they find a faint companion orbiting it, confirming their theory. This finding fits a larger pattern. Most dwarf planets out here have moons, perhaps formed from gentle collisions that didn't fling debris away but kept it bound. Each discovery in the Kuiper Belt adds a small piece to the puzzle of how our solar system came to be, frozen fragments that tell stories older than the Earth itself. After travelling so far, it's time to look back, not at a planet, but at the instruments that made this journey possible. Hubble has now been in space for more than 33 years, and its mission may last until 2040. Yet a new eye has joined it, the James Webb Space Telescope. Unlike Hubble, which sees primarily in visible and ultraviolet light, Webb captures the universe in infrared, revealing what the human eye cannot see: the heat of distant galaxies, the glow of newborn stars, and the faint rings of giant planets. When Webb turned its gaze toward Jupiter, it showed us auroras, glowing in infrared delicate rings, shimmering faintly, and storms glowing through haze. Neptune appeared in soft blue light, its rings visible for the first time in decades. Saturn too glowed differently, its darkened planet contrasting against icy rings that reflected the sun's warmth. Some might see Webb as Hubble's replacement, but in truth, they are partners, not rivals, two halves of the same vision. One reveals what is visible, the other what is hidden. Together, they give us a fuller picture of the cosmos, light and shadow, science and wonder working hand in hand. For over 3 decades, Hubble has changed how we see the universe and how we see ourselves. It showed us galaxies forming, stars dying, and even our own solar system as we've never seen it before. As we look ahead, to what the next generation of telescopes will uncover, we can pause to appreciate what this one has already given us, a vision of the cosmos in motion, alive and deeply connected to our own story. Every image Hubble has sent back from the moon's reflection to the frozen edges of the Kuiper Belt carries the same quiet message that curiosity is light, and the act of looking outward is also a way of looking within. We are explorers not just of space, but of meaning, seeking to understand our place in a universe that never stops changing. This has been Cosmic Compass. Until next time, keep looking up and let the stars guide your curiosity.